তিনটি না এমনি চা বানাবি, তুই তো 7:30 করবি। দুধ খাবি?
Good evening, class. So today what we are having the topic, where topic is straight line. Some basic concepts we know about the straight line are slope, which we will be going to represent by m. If we will be having more than one straight line, then the slopes will be represented by m1, m2. Okay. The angle between two lines tan theta equals to mod m1 minus m2 upon 1 plus m1 m2, and the various forms of the equations. Okay, so let's go to our first question. Our first question is the equation of the line which passes through the point 3, 4 and the sum of its intercepts on the axis is 14. So we know that if we are having some straight line, and the equation of the straight line, yeah, correct, and the equation of the straight line is such that it makes the intercepts a and b. So the point will be a comma 0 and this point will be 0 comma b. So the equation of the straight line will be x upon a plus y upon b equals to 1. Okay. So what we are given is, we are given the straight line passes through this point 3 comma 4. So the coordinates x and y will satisfy this condition. So first equation will be 3 upon a plus 4 upon b equals to 1. Now, it is also given that the sum of the intercepts on the axis is 14. And we know that intercept on x-axis is a and intercept on y-axis is b. So a plus b equals to 14. So this is our second equation. What we are going to do here is we are going to solve these two equations by simple method of substitution. So let's say b equals to 14 minus a. Substituting the value of b in here, we will get 3 upon a plus 4 upon 14 minus a equals to 1. So when you will solve these equations, you will get a quadratic equation in a. See, when you will take the LCM, so it will be 3 14 minus a plus 4a equals to a into 14 minus a. Now we can easily solve this equation, and on solving this equation we will get a quadratic equation in A. So we will solve this quadratic equation by the method of splitting the middle term. So we need two numbers whose product is 42, and on adding or subtracting them we are getting 13. So that is minus 7 and minus 6. So it will be a square minus 7a minus 6a plus 42 equals to 0. A will take out common, so a minus 7 minus 6 will take out common, a minus 7 equals to 0. This and this here, we will take a minus 7 common from these two terms into a minus 6 equals to 0. Now look at this. This is a product of two factors, and the product of two factors is 0. That means either of the one is 0. So either a will be 7 or a will be 6. So first of all, we will put a equals to 7 and find the value of b. And b, we have known that a plus b was equals to 14. So b is 14 minus a. So from here, we can get the value of b. So b is 7. Substituting the value of a is 7. So we are getting these 2 points a and b, and again on substituting a equals to 6, we will get b equals to 8. So our two equations will be x upon 7 plus y upon 7 equals to 1, and in the second it will be x upon 6 plus y upon 8 equals to 1. What concepts we have required in this question? First, equation in intercept form. So in intercept form, the equation is x upon a plus y upon b equals to 1. Okay. Now let's move to our next question. Yeah, sure. The question was the equation of the line which passes through point 3 comma 4 and the sum of its intercept on the axis is 14. Now, moving to the next question, we are having if the intercept made by the line between the axes is bisected at this point, then the equation is. So, what we can do here is we can clearly see we have a line which makes some intercepts on the axis, that is on x-axis and y-axis. So, let's have this equation of a line, and let's say its intercept on x-axis is a, so this coordinate will be a comma 0, and intercept on y-axis is b, so this coordinate will be 0 comma b. We already know the equation of the line making intercepts a and b on x and y-axis respectively is x upon a plus y upon b equals to 1. Now what we are given is we are given if the intercept made by the line between the axes is bisected at this point x1 y1. So there is some point P whose coordinates are x1 comma y1 and it bisects these intercepts. So we can say that P is midpoint of, let's name these 2 points A and B. So midpoint of A and B. So from midpoint formula x1 will be equals to A plus 0 by 2. This implies that a equals to 2x1. Similarly, y1 will be equals to 0 plus b upon 2. We are using the simple midpoint formula x1 equals to the sum of the two coordinates divided by 2. Similarly, y1 equals to sum of the two y coordinates divided by 2. So from there, 2 will be taken that side and we will get b equals to 2y1. Substituting the value of a and b in our equation of straight line, we will get x upon 2x1 plus y upon 2y1 equals to 1, or we can say x upon x1 plus y upon y1 equals to 2. So our required answer is A. Now let's move to our next question. Now this is the type of question usually is asked in your exams, and it is the distance of the point 2 comma 3 from the line measured along this line. So for the distance and the line and the distance between a point and a line, we are having two different concepts. First of all, if we are having some point x1 y1 and we are having an equation ax plus by plus c equals to 0, and we have drawn a perpendicular, let's say it is on point M. So PM is our perpendicular distance of point P from line. So we can find the value of Pm by using the simple formula mod of ax1 plus by1 plus c upon under the root a square plus b square. This formula is used only when we are having the perpendicular distance. But in this question, we are having some line. Let's say this is our 2x minus 3y plus 9. 2x minus 3y plus 9 equals to 0, and we are having another line, this one, x minus 1 plus 1 equals to 0, x minus y plus 1 equals to 0. Now we are having this point 2 comma 3, and we are required to measure this distance along the line that is a distance parallel to this line. So this is our P, we said this is our point M. So for this type of questions, we will be using the parametric form of the line, and the parametric form of the line is if we are having a line between the 2 points x1, y1, x2, y2, let's say r is the distance between these 2 points, and tan theta is slope. So our equation is x2 minus x1 by cos theta is equals to y2 minus y1 by sin theta equals to r. So this line PQ, we need to find two things. First of all, let's say we have a point here, and this coordinates are x2, y2. The coordinates x2, y2 will be satisfied by the line 2x minus 3y plus 9 equals to 0. Now, we are not having the slope of PM, but it is given that this distance is measured along the line x minus y plus 1 equals to 0. So we are having slope of this equation. For a line ax plus by plus c equals to 0, slope is minus of a by b. On comparing, we will get slope equals to 1, that is tan theta equals to 1. So sin theta and cos theta, sin theta will be 1 by root 2 and cos theta will be 1 by root 2. Now applying the same concept here, we will get x2 minus 2 upon cos theta will be equals to y2 minus 3 upon sin theta equals to r. R is the distance. So from here, these two equations, we can find the value of x2 and y2. I am writing these two values down here. So x2 will be r cos theta plus 2 and y2 will be r sin theta plus 3. Now substituting these two values of x2 and y2 in our equation 2x minus 3y plus 9 equals to 0, we will get the value of r, because we already know the value of cos theta and sin theta, which is 1 by root 2 and 1 by root 2. So this was the values. This is our x2, this is our y2. If this point is lying on this line, then we are satisfying it. So we will be having 2 into 2 plus r by root 2 minus 3 into 3 plus r by root 2 plus 9 equals to 0. That is 4 plus 2 r by root 2 minus 9 minus 3 r by root 2 plus 9 equals to 0. So we'll be getting minus r by root 2 equals to minus 4. So r will be 4 root 2. So our required answer is 4 root 2 P. So what we have done in this question is, first of all, we have to write it in the form of this parametric form, and you can solve it. You can also do one more thing. You can find the equation of a line passing through 2 comma 3 and parallel to this line, because we can easily find the equation of line PM. We are having 1 point and slope we are having 1, and we can also find this point of intersection, and then we can apply the distance formula. Let's move to the next question. Our next question is, we are having an equation of a line and A, B, C are the 3 points. Then we need to find which are points are on the same side and on the opposite side. Now, if you write the equation of this line ax plus by plus c equals to 0, then this means all the points, all the x comma y coordinates which will be lying on this line will satisfy this condition, that is, for this condition this value will be 0 for all the points lying on this line. If a point is lying on the either side, then the LHS can be positive or negative. But we are not very sure when the LHS will be positive or when it will be negative. That depends upon this arbitrary constants A, B, and C. So first of all, what we are going to do is we can write the equation in the form x plus 2y minus 3 equals to 0. Then let's put point A in it. So minus 1 plus 2 into 3 minus 3. So we will be getting minus 1 plus 6 minus 3. This value will be 2, which is a positive value. Now for point B, that is 2 plus 2 into minus 3 minus 3. This value will be minus 7, it will be negative. And thirdly, for point C, the value will be 4 plus 2 into 9 minus 3, and it is 9 to the 18, this is 19, and this value is positive. So if the value is positive, that means the 2 points lie on the same side, and this value is negative, matlab it lies on the opposite side. So A and C are on the same side and B is on the other side of the line. So answer is C. Moving to our next question, we have to find the equation. We are given the equation of two equal sides of an isosceles triangle are this and this. 7x minus y plus 3 equals to 0 and x plus y minus 3 equals to 0. And its third side passes through the point 1 comma minus 10. Then the equation of the third side is, since it is given that it is an isosceles triangle and the two sides, let's say A, B, C, these two sides are equal. So this angle will be theta and this will be theta. Now this line passes through some point 1 comma minus 10. It may lie outside this or it may lie in this section or it may lie in that section. Okay, anywhere on the line BC. Now what we are going to do is we are having the equation of this line AB and we are having the equation of line AC. So from the equation of line AB we can find out its slope. M1 it will be 7 and AC its slope will be minus 1. Let's say M2. Let's say the slope of line BC is M. Since it is making an angle theta, so we are having tan theta is equals to mod of M1 or M minus M1 upon 1 plus M into M1. And similar value we will be having here M minus M2 upon 1 plus M into M2. So on solving, M minus 7 upon 1 plus 7M equals to M minus of minus 1 upon 1 plus M into minus 1. So we will be having M minus 7 upon 1 plus 7M equals to M plus 1 upon 1 minus M. On simplifying this equation and solving it, we will get the value of M as minus 3 or 1 by 3. Okay, so we are having the two values of M here and we are already having the point was 1 comma minus 10. So the equation of line having slope M and passing through point x1 y1 is y minus y1 equals to m into x minus x1. Substituting this value, this is x1, y1, this is the value of m minus 3 and 1 by 3. We will get one equation and the other equation, and we will be having the two equations. So the answer is C. So this is correct. And so our answer was 3x plus y plus 7 equals to 0, or x minus 3y minus 31 equals to 0. So C is the correct answer. So what you have to take care about is, you have to take care about this formula of slope. If we are having the slopes m1 and m2 and the angle between the two lines is theta, then tan theta is mod of m1 minus m2 upon 1 plus m1 m2, and we are having m here, so m minus m1 upon 1 plus m into m1. Now moving to the next question, the triangle formed by these three lines is, so we are having these three lines and we need to find the type of triangle formed. So let's say we are having x plus y equals to 0, 3x plus y equals to 4, and x plus 3y equals to 4. So for this one, slope m1 will be minus 1. For this one, slope m2 will be minus 3. And for this one, slope m3, it will be minus 1 by 3. So we can say we are having this angle A, angle B, angle C. So tan A will be mod of m1 minus m2 upon 1 plus m1 into m2. So tan A, it will be minus 1 minus 3 upon 1 plus minus 1 into minus 3. On solving, we will get 2 by 4, that is 1 by 2. Similarly, tan B we can find out. Tan B is the angle between these two lines. So slopes we will take m1 and m3. So it will be mod of m1 minus m3 upon 1 plus m1 into m3. So tan B will be equals to mod of minus 1 minus of minus 1 by 3 upon 1 plus minus 1 into minus 1 by 3. On solving, 3 will go that side, minus 3 plus 1, it will be minus 2, and this will be 3 plus 1, so it will be 2. So tan B we will be getting 1 by 2 again. And tan C, this is the angle between m2 and m3. So mod of m2 minus m3 divided by 1 plus m2 into m3. So tan C will be minus 3 minus of minus 1 by 3 upon 1 plus minus 3 into minus 1 by 3. So tan C will be minus 9 plus 1, that is minus 8 by 3, and this will be cancelled out, divided by 2. So we will be getting tan C equals to 4 by 3. See, here tan A and tan B are same. So these two, tan A and tan B are same. These two angles are equal. So it is an isosceles triangle. Now, let's move to the next question. Our next question is, if A, B, and C are the 3 points, then the angle between BA and BC is. So we can find the slope of line BA. BA will be 3 minus 1 upon 2 minus of minus 2. So how we are going to find this is, if we are having 2 points x1 y1 and x2 y2, then the slope of line PQ is y2 minus y1 upon x2 minus x1. Using this concept, we can see y2 is 3, y1 1, x2 2, x1 minus 2. So we'll be getting 2 by 4, that is 1 by 2. And we can find the slope of the line BC. That will be minus 4 minus 3 upon minus 2 minus 2. So that will be minus 7 upon minus 4, that is 7 by 4. Now applying the formula of tan theta is equals to mod of, so putting the values, we will getting 1 by 2 minus 7 by 4 divided by 1 plus 1 by 2 into 7 by 4. Four minus 14 by 8 divided by 8 plus 7 by 8. So that will be minus 10 upon 15. On solving, we will be getting 2 by 3. So answer is tan inverse 2 by 3. Now, moving to the next question. A straight line L is perpendicular to this line. 5x minus y equals to 1. The area of the triangle formed by the line L and the coordinate axis is 5. Then the equation of the line is, we are having a straight line L which is perpendicular to this line, 5x minus y equals to 1. Let's say L has x coordinate, intercept on x coordinate A and on y coordinate it is B. So the area of triangle will be half AB, and it is given that it is equals to 5, so AB is equals to 10. Now we need to find the equation of this line. So already we know the equation of line is x upon a plus y upon b equals to 1. From here this slope will be minus of b by a. If you write it in the form of y equals to mx plus c, that is y upon a minus x upon a plus 1. So y will be minus b by ax plus b. So from comparing it to the equation y equals to mx plus c, we will get m equals to minus b by. And the slope of this line is 5. So we are having minus b by a into 5 is equals to minus 1. So 5b equals to a. Putting this value of a here, we will be getting 5b square equals to 10. So b square will be 2. So b will be equals to plus minus root 2. Similarly, a will be equals to 5b. So it will be plus minus 5 root 2. So our equation will be x upon 5 root 2 plus y upon root 2 equals to plus minus 1. So on solving, x plus 5y equals to plus minus 5 root 2. So our answer is C. Clear? Now, let's move to the next question. Read the question, everybody. Now, the sides AB, BC, CD, and DA of the quadrilateral have these following equations. For side AB, the equation is x plus 2y equals to 3. For side BC, the equation is x equals to 1. For side CD, the equation is x minus 3y equals to 4. And for side DA, the equation is 5x plus y plus 12 equals to 0. Then we need to find the angle between the diagonals AC and BD. We are having A, B, C, D. We are having this equations line x plus 2y equals to 3. We are having this x equals to 1, this x minus 3y equals to 4, and 5x plus y plus 12 equals to 0. Now, we need to find the angle between AC and BD. For that, if we will get these 2 points AC, then we can find the slope of line AC. And similarly, if we will get the points B and D, we can find the slope of lines BD. And we can use the formula of tan theta to get the angle between these two. Now, how we are going to find these coordinates? Just we have to solve these two equations. For example, if we will solve these two equations, then we will get x equals to 1. Obviously it is given, and putting x equals to 1 here, we will get 1 plus 2y equals to 3, that is 2y equals to 2. So on solving, y equals to 1, so we will get the coordinates 1 comma 1. Similarly, you can solve for these two. On solving for this two, you can get x will be 1, and putting x equals to 1 minus 3y equals to 4, so 3y will be equals to 3, so y will be equals to minus 1. Similarly, we can solve these two equations to find these 2 points. So when you will solve, the points you will be getting here is A, B, C, and D. From this, slope of line AC is minus 1 and slope of line BD is 1. We already know that if two lines are, first case is parallel, then the slopes are equal. And secondly, perpendicular, then the product of slopes is minus 1. Here we can see this product comes out to be minus 1, so the two lines are perpendicular to each other. Now let's go to the next question. The equation of the line through the point of intersection of the lines x minus 3y plus 1 equals to 0 and 2x plus 5y minus 9 equals to 0, and whose distance from the origin is root 5 units. If you are having some line, say ax plus by plus c equals to 0, then its perpendicular distance from origin, this OP, is mod of C upon under the root A square plus B square. Now, we have to find the equation of the line whose point of which passes through the point of intersection of these two lines. So what you can do is, you can either solve these two lines, find the point of intersection, and then put this in the equation and then solve it, or we can use the concept that a line passing through the intersection of lines L1 and L2 is L1 plus lambda times of L2 equals to 0. So here we will be having x minus 3y plus 1 plus lambda times of 2x plus 5y minus 9 equals to 0. On simplifying, we will get 1 plus 2 lambda x plus minus 3 plus 5 lambda y plus 1 minus 9 lambda equals to 0. Now, using this concept, value will be, see, we are having this, A is this, B is this, C is this. Compare it, the distance is given root 5, so it will be 1 minus 9 lambda divided by under the root 1 plus 2 lambda whole square plus minus 3 plus 5 lambda whole square is equals to root 5. Okay, so what we are going to do is, we are going to square both the sides and simplify it. So we have got up to this value on squaring, and when you will simplify it, you will get a complete square, and from this you will find the value of lambda as 7 by 8. Hence the required line is, we will put the value of lambda in here and simplify it to get the equation of this straight line. Now let's move to the next question. Our next question states that we are having a variable line that passes through the fixed point P. If the algebraic sum of the perpendicular distance of the points 2, 0, 0, 2 and 1, 1 from the line is 0, then P is. So let's say the equation of line is ax plus by plus c equals to 0. Let's say this with 2, 0, its distance is d1, with 0, 2 it's d2, and with 1, 1 it is d3. So d1 will be 2a plus c upon under the root a square plus c b square. d2 will be 2b plus c upon under the root a square plus b square. And d3 will be a plus b plus c upon under the root a square plus b square. Now, it is given that d1 plus d2 plus d3 equals to 0. On adding, we are having the same value of denominator, so numerator will be directly added. We will be getting 3a, 3b and 3c equals to 0, that is a plus b plus c equals to 0. Now, we were having the equation ax plus by plus c equals to 0, and we have got the condition a plus b plus c equals to 0. This condition is satisfied when x equals to 1 and y equals to 1. So on comparing, we can say that these straight line will always pass through the point 1 comma 1. So our answer is A. Now moving to the next question. The bisector of the acute angle between the two lines 3x minus 4y plus 7 equals to 0 and 12x plus 5y minus 2 equals to 0. See, we are having the two lines. Let's say this and this. So, what property the bisector will behold? The bisector, if we will take the perpendicular distance from any of the two lines, let's say this line we are having a1x plus b1y plus c1 equals to 0, and this is a2x plus b2y plus c2 equals to 0, and we are having some point h comma k on the bisector, then p and r. So the distance PQ will be equals to PR. Since it is a bisector, this angle and this angle will be equal, and the two angles are 90 degree and one side is common. Here OP is common. So these two triangles OQP and ORP, these two triangles are congruent triangles. So due to the property of congruency, we will say PQ will be equals to PR. Now we already know if PQ will take, then it will be A1H plus B1K plus C1 upon under the root A1 square plus B1 square. And for PR, it will be A2H plus B2K plus C2 upon under the root A2 square plus B2 square. But we will take mod both the sides because we are taking out the distances. So if we will take out the mod, then the value will be either plus 1 or minus 1. So the equation will be a1h plus b1k plus c1 upon under the root a1 square plus b1 square. We'll take this term on this side plus minus a2h plus b2k plus c2 upon under the root a2 square plus b2 square equals to 0. Now, see, this condition will be followed by both the bisectors, acute angle bisector as well as obtuse angle bisector. So how we are going to know that the bisector we are getting is acute or obtuse? You will be getting two bisectors. Now let's say this is our line. So our one bisector will be this one, and one bisector will be this one. If we'll take this angle as theta, this angle as something say phi, if we will get the angle between the lines is L1, L2 and our bisector is L and L dash. So when tan theta will be positive, that means theta will be 2 theta will be less than 90 degree. Oh, sorry. Let's say if tan theta is less than 1, then theta will be less than 45 degree. So the angle between the two bisectors, that is 2 theta will be less than 90 degree. So it will be our L will be our acute angle bisector. Similarly for phi, we can see if we will get for some different for the other bisector, we are getting tan phi greater than 1. So that means phi is greater than 45 degree, and this angle between the lines is 2 phi. So 2 phi is greater than 90 degree. That is, we are getting L dash, that is obtuse angle bisector. So in this question, we are having the two straight lines, and we will be putting this condition to get two equations of the bisector, and then with equation 1 and one line we will find the angle tan theta, and if that value of tan theta will come out to be less than 1, then it will be an acute angle bisector. If that value will come out to be greater than 1, then it will be an obtuse angle bisector. So on solving, we have got this equation and this equation. Now, the angle between the given line and the bisector 11x minus 3y plus 9 we can find, because we are having the slope here m1 equals to 3 by 4 and we are having the slope here m2 equals to 11 by 3. Oh, yeah. And on solving, we will get tan theta less than 1. That means theta is less than 45 degree. That means 11x minus 3y plus 9 equals to 0 is acute angle bisector. So our answer will be C. Now, moving to the next question. The equation of two straight lines through the given point 7, 9 and making an angle of 60 degree with this line. So the given line is x minus root 3y minus 2 root 3 equals to 0. So let's find the slope of this line. Let's say m1. The value of m1 will come out to be 1 by root 3. Now it is given that the angle theta is 60 degree. So let's say that straight line equation is y minus 9 equals to m into x minus 7. We need to find the value of m. So tan theta is mod of m minus m1 upon 1 plus m into m1. Tan theta, theta is 60 degrees, so root 3 equals to mod of m minus 1 by root 3 whole upon 1 plus m by root 3. Removing the modulus sign, we will put plus and minus sign. M minus 1 by root 3 equals to plus minus root 3 into 1 plus m by root 3. M minus 1 by root 3 equals to plus minus root 3 plus minus root 3 into m by root 3. So let's take positive sign first. Well, we should take it from here only. Taking positive sign, m minus 1 by root 3 equals to root 3, 1 plus m by root 3. So m minus 1 by root 3 equals to root 3 plus m. So what happened here is, you will get this type of equation and people usually cancel m and m and they reach nowhere, but we can do it like m into 0 is equals to root 3 plus 1 by root 3. So m will be equals to some value divided by 0 that is tending towards infinity. So our slope will be something upon 0, or we can say the angle theta 1 will be 90 degree. So the equation will be y minus 9 equals to some value by 0 into x minus 7. The 0 will come out this side and it will be x equals to 7. And now taking the negative sign, we will get find m minus 1 by root 3 equals to minus root 3 1 plus m by root 3. On solving this, you will get m equals to 1 by root 3 minus root 3 whole upon 2. Substitute this value and you will get the other equation. Okay. And on solving, we will get x plus root 3 y equals to 7 plus 9 root 3. So our correct answer will be A. What happened here is, basically Most of the students, when they feel like m into 0 equals to some value, they leave the question here only. But try to understand this is equals to m equals to some value divided by 0 that is tending towards infinity. That means the value of slope can be 1 by 0 or it can be 0. See, we are having tan theta as slope, and tan theta acquires all the real number values from minus infinity to plus infinity. So you should not neglect this thing. If you are getting m into 0, that means write up, put it m equals to 1 by 0 and solve the equation. Or what you can do is, if you are not comfortable using this, you can use y minus y1 equals to m into x minus x1. So put 1 by m here. So here we are having 1 by m equals to 0, and that will be very easy. We will be having this whole term 0. So x minus x1 equals to 0 will be our solution. Now, moving to the next question. If P1 and P2 be the perpendiculars from origin upon the two straight lines, x sec theta plus y cosec theta equals to a, and x cos theta minus y sin theta equals to a cos 2 theta respectively, then we need to find the value of 4p1 square plus p2 square. If we are having a perpendicular from the origin to the line ax plus by plus c equals to 0, then this length OP we have already seen, it is c upon under the root a square plus b square. So for the first condition, x sec theta plus y cosec theta minus a equals to 0, we will be having p1 equals to a upon under the root sec square theta plus cosec square theta. On simplifying, P1 will be a upon under the root 1 upon cos square theta plus 1 upon sin square theta, which will come out to be a sin theta cos theta, because on taking LCM, sin square theta plus cos square theta will be 1. So P1 is a sin theta cos theta. Similarly, for P2, it will be a cos 2 theta divided by under the root cos square theta plus sin square theta. Whether this coefficient is in minus, but it will be x cos theta plus y of minus sin theta. So the square of minus sin theta will be sin square theta, and this whole quantity will be 1. So P2 is a cos 2 theta. Now, what we can do is we can change this sin theta cos theta into sin 2 theta, because we can see here we are having cos 2 theta. So multiply by 2 both the sides, and you will be having 2p1 equals to a sin 2 theta. On squaring and adding, you will get 4p1 square plus p2 square equals to a square sin square 2 theta plus a square cos square 2 theta, and sin square 2 theta plus cos square 2 theta will be 1. So our answer is A. Now let's move to the next question. The diagonals of the parallelogram PQRS are along these two lines, x plus 3y equals to 4 and 6x minus 2y equals to 7. Now we can find the slope from here, that m1 will be minus 1 by 3, and from the second line the slope m2 will be 3. It is clearly m1 into m2 equals to minus 1, that is the two diagonals are perpendicular. So this is a case of rhombus. Now let's move to the next question, and our next question is, we need to find the orthocenter of the triangle whose vertices are A 0 comma 0, B 3 comma 4, and C 4 comma 0. Now, what is an orthocenter? Orthocenter is the point of intersection of the altitudes. So we are having the point 0 comma 0 here. It will be on the x-axis A and C both. It is 4 comma 0, and somewhere here we are having 3 comma 4. If we will draw a perpendicular, then we can find the altitude through A. We are having this slope as again 0, and we don't need to solve this much. Let's name this point A, B, and C. From A, we have drawn this is x equals to 3 line, and this altitude from A to D, it will be y minus y1 equals to some slope, and the slope of this line BC we can find out by y2 minus y1 upon x2 minus x1, so it will be 4 by 1. So the slope of AD, it will be, oh sorry, that is 4 minus 0 upon 3 minus 4. So it will be minus 1. So slope of AD will be minus 1 upon slope of BC. So slope of AD will be 1 by 4. So y minus y1 equals to 1 by 4 x minus x1. So y will be x by 4. So this is the equation of line AD, and we are having this x equals to 3 as our other altitude, and this point of intersection is our orthocenter. So the coordinates will be x coordinate is 3, and putting x equals to 3 here, our y coordinate will be 3 by 4. So the answer is 3 comma 3 by 4. So how you are going to find the orthocenter? For orthocenter, you need to find the point of intersection of the altitudes. We are already having the altitude of this line, since it is parallel to x-axis. So the altitude will be parallel to y-axis. So its equation will be x equals to 3, and we have found out the value of equation of AD. Clear? So that's it for today. Uh, Thank you, class.